Now, this is for reflex media. Now, this is the rod which is closing your this hole for 25 to 30 minutes so that your whole liquid should go back into the column for the equilibrium. Now, my equilibrium has been generated. Now, I will start the second thing as I told you for fractional distillation, interaction media and reflex media is required. Now, reflex media. Here you can see this is a glass rod. And the upper side of this rod, there is a iron part.
Yes.
You can see this is the iron part. Okay. Now here when you go through the method ASTM 2892, their reflex ratio is written 5:1, or you can say R equal to 5/1. But here my condition will be 10/1 or 10:1. Means more careful. As you told, is there any disturbance in the data from the refinery or here? There is no any, because my reflex ratio is again 10:1, which is higher than in ASTM. So I will maintain my reflex ratio 10:1. Okay. Now what is the role of this thing? Because this is a manual. Here you will find the science which is used here only up to 10th class. This is a solenoid coil. This solenoid coil has been connected through a watch. There is a watch, and this watch has been connected through an electric point. Got my point? Now, when I switch on this electric point, what happens? My watch has been selected the timer, which is 10 seconds to 1 second. Means for 10 seconds, there is no any current flow inside the solenoid coil. If there is no any current flow, so this rod will remain down to closing this hole.
Yes.
But for 1 second, there will be current flow inside the solenoid coil. If there is a current flow inside the solenoid coil, it will generate the magnetic field.
And then it
Exactly. And if it is generating the magnetic field, as I told you, inside the rod there is the iron part. So that magnetic field is lifting your iron rod upwards
and opening the gate.
and opening the gate. Now think of only 1 second, your rod is going up and this hole is opening and you are getting the distillate only for 1 second. So that is why I've told you, if I am taking the sample of 20 liter to completing that distillation up to 370 degrees centigrade, it is taking 5 days. Why it is taking 5 days? Because I am getting only 4 to 5 ml per minute distillate as a product. So R equal to L upon D means L is a liquid which is going back into the column for the interaction. So for 10 seconds, this rod is resting down, and whatever the vapor which is reaching to the condensation area, that is going back into the column for the interaction, and only for 1 second it is lifting up, and through that distillate is passing through into the fraction cutter into the receiver. That distillate you are getting as a product.
Why the cooling is the two-step, not one-step?
Double stage cooling.
Double stage cooling is there.
Why?
Two stage
Why?
Actually there's, see,
Step 1 and step 2. Why only step 1?
It's not enough.
I could not
Cooling
understand.
is step 1.
This,
Why you have
so this is a
double
two
cooling?
part. This
Yeah,
is
two parts. Why? One
This
part.
is your fraction cutter. Now, why is that is there? No. Let me first. Once, for example, you have started the fractional distillation from C5 onwards, because you are getting the liquid from C5 onwards. Now, once your naphtha has been finished, because the boiling range of the naphtha is IIP to 140 degrees centigrade. See, this is not a refinery. In refinery, there you will find the distillation that is called continue process. Means continuously you are sending the crude oil into the furnace, and you are getting the things everything simultaneously. But here, once you have taken the batch, because this is a batch distillation.
Yes.
Once you have taken the batch, you will get the things one by one. So if you will see, okay, my temperature is raised to 140 degrees centigrade. Now what you will do? Now you come to know, okay, my naphtha has been finished. So how will you collect that naphtha? And second thing, your beyond that means 140 to 250 degrees centigrade cut, that should not mix with the naphtha. So for that, that is why it is given once 140 degrees there.
The draining only naphtha.
Let me finish first. Once there is a 140 degrees centigrade, now what you will do? You will close this one. Okay. Now the distillate beyond 140 degrees centigrade, that is collecting inside this fraction cutter, and the distillate which is collected inside this receiver, okay, that is your naphtha. That has to be collected in your sample water.
This is naphtha.
This is naphtha now.
This.
Now again the caro cut from 140 onwards.
Oh.
So that is why it is there. That is why the name of this particular thing is fraction cutter. It is cutting the fraction. Okay. Okay. So the things which you have collected inside, that is your naphtha. Maybe naphtha may be higher. Okay, no problem is there. Okay, if the temperature is 70 degrees centigrade and this receiver has been filled up,
Yes.
no problem. You just close it and you can collect it inside the
Right.
water. Otherwise, then it will become
So-
empty. Again close. Then again it start
So, sir, you say we maintain this at negative 20.
at
What
minus
is-
20 degrees
What
centigrade.
about this one and this one?
Again same minus 20 degrees.
Both, yeah,
It will
maintain it
remain at
like
minus
a
20 degrees
minus 20.
This
centigrade.
is this
Till
water from humidity for air.
yes, exactly.
For the-
Because yes. Yes, you will run condenser at minus 20 degrees centigrade up to when the temperature will reach up to 65 degrees centigrade.
65 degree.
When once 65 degrees centigrade reached, now you will have to remove the water, this methanol or cooling.
Yes.
You will add this simple tap water.
Okay.
After that, because we know that our boiling point compound is higher. Okay,
So
but
we add the
up to
water
65 degree.
with 40 centigrade water or
And
4
simply
centigrade.
room temperature,
Yeah,
you
room
can flow
temperature,
it.
maybe 20 or 15
No problem is
depending.
there. But yeah, it should not be a 40 degree or 45 degree.
Okay, so after
After 65 degrees
65
centigrade,
degree,
you can run the simple tap
so
water.
we can remove
Yeah, we
the
can-
alcohol and then
We can, methanol, we can remove whole the methanol. That will collect it inside this. Okay, then you will connect the water. Simple tap water. But but one thing keep in your mind, the temperature of the tap water should not be more than 35 degrees centigrade.
so where do we monitor the water temperature?
You
What
can check
machine
the
is-
thermometer.
Where?
You can. This is the tap water. You take the thermometer and collect into the beaker and check the temperature. It's a simple way. Because this is manual. Everything is manual.
Okay, I thought this maybe alcohol or water is rotating in the system.
See, no problem is there because it is rotating and going outside in the drain. Same water is not circulating. Every time it is a new water is coming. This is cooling bar. Cooling bar. There is a methanol
The
inside.
liquid inside what?
Methanol. This methanol is circulating inside. This is double wall jacketed and it is circulating inside this and this.
Another
Sir, how about this part? The function of this part?
Exactly.
Naphtha. This system. What is
Again, naphtha has been completed.
again naphtha?
See, once the temperature is 140 degrees centigrade has been reached, okay, you have collected whole the naphtha.
Yes.
That naphtha you will have to collect into your receiver, whether it is bottle or something, and it has to be kept inside the freezer.
Yes.
Okay, after draining this.
Yes.
Because you will have to collect again the further the kerosene you will have to collect inside this.
Kerosene.
Yeah. So the first cut is initially C1 to C4 your LPG potential.
The first one naphtha. The second kerosene.
You just let me finish first. First you will collect LPG potential. Got my point? Or you can say C1 to C4. Okay, that is the first part of the crude oil. C1 to C4 or LPG potential or debutanization of the crude oil. Got? Now C5 onwards. C5 to 140 degrees centigrade, that is your naphtha. Okay. Then 140 to 250 degrees centigrade, that is your kerosene. And then 250 to 370 degrees centigrade, that is your diesel, or you can say straight run diesel. All these cuts are straight run. Now 370 plus, that is your long residue. The crude oil which we are distilling by ASTM 2892, we can get LPG, naphtha, kerosene and diesel. Now sufficient. Off. Beyond that, we are unable to distill the further by this ASTM 2892. We will have to keep that 370 degree. Another distillation method, that is ASTM 5236, which is pot distill high vacuum distillation unit. POT pot STI double still high vacuum distillation unit. There you will find the pressure which is always less than 1. Now, but here also LPG, complete naphtha and half part of the kerosene. Half part means up to only 200 degrees centigrade. You are going to distill the crude oil up to 200 degrees centigrade in atmospheric pressure. Simply. But beyond that, you are unable to distill further. Why? There will be a problem. What type of problem? Yes, what type of problem? Decomposition, cracking. If there is a cracking inside, then what is the use of distillate which we have got the up to 200 degrees Celsius? So to avoid the cracking, we will have to change that 200 plus under vacuum. Okay, so you can explain somebody the distillation process which we have seen in Advanced Chloride Research Centre. There we can distill the crude oil in atmospheric pressure up to 200 degrees centigrade. After completing the distillation up to 200 degrees centigrade, stop the distillation here only. Because
They ask asphalt drain from where?
we can drain from here. After completing the distillation up to 200 degrees centigrade, stop, let it cool down at room temperature. Because you will have to just make the material balance. Again, initial weight you have. After distilling the crude oil up to 200 degrees centigrade, again you will have to take the weight. Because there are 2 or 3 type of losses. One is first end loss. What do you mean by first end loss? First end loss. This is again a question. Anybody can ask you, what do you mean by first end loss? If you are doing the distillation, said what do you mean by first end loss? First end loss. First end loss means transferring the liquid distillate. See, once you have collected the naphtha over here, up to 200, half part of the kerosene over here, you have drained that particular naphtha in a bottle and again in a second bottle. But during transpiration of the liquid, there will be a little bit 1 or 2 drops left, right, or little bit liquid inside the receiver. That is called your first end loss. Yes. End. END, end. First end. In. अंग्रेजी मुश्किल है. First. 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 END, end. So this is your initial. You can say the initial loss during handling. You can say that also handling loss. Okay. Now second loss is, there are 2 types which is very important. Somebody can ask you, what do you mean by static hold up and dynamic hold up? This is again very, very important. Static hold up and dynamic hold up. Can anybody explain static and dynamic?
Stable and moving.
Dynamic hold up or loss, you can say. Static hold up or loss, a dynamic hold up, or you can say loss. So now let me first explain you. First I will let you know about static hold up. This is very important while you are doing the distillation process. Static hold up means after completion of the fractional distillation. Once you have completed the distillation up to 370 degrees centigrade. So after completion of the distillation, what is the loss of the complete feed? It doesn't mean if you are taking 100 ml of the sample, you are going to get 100% back. It is not possible. So there is a little bit loss. That is your called static hold up. So completion of the distillation, how much losses are there, that is your static hold up. Now dynamic hold up, this is very important. What do you mean by dynamic hold up? So dynamic hold up means how much maximum liquid can hold by the distillation column in a adiabatic condition, or in a normal condition, or in a without flooding position. So many things are there. Dynamic hold up means how many liquid can hold by the column in a normal adiabatic condition. Hold how many liquid can hold by a column
This one.
during that distillation column. This is dehydration column, simply that distillation column. So how much liquid can hold by a column during the distillation in a normal adiabatic condition. So why I have written this normal adiabatic condition? Your column should be in equilibrium. There should not be any flooding. There should not.
From what to what? The number.
Adiabatic condition means there should not be a flooding. Again question is arising, what do you mean by a flooding? So many questions are there. Flooding. What do you mean by flooding? Again this can be asked you. What do you mean by flooding? Flooding. Flooding point.
Carryover of liquid with vapor.
The definition is the velocity of upcoming vapors is higher than the downcoming liquid, because you are sending the vapor to the condensation area, then this condensed liquid is going back into the column for the interaction. So if the velocity of the upcoming vapor is higher, so your liquid is not going to back into the column for the interaction. So what will happen? Your column will suddenly filled up with the liquid. It means there is no any segregation, or there is no any separation is taking place inside the column. And you will find if there is a disturbance, if there is a flooding inside the column, you will find the disturbance in temperature. Once your temperature will become 40, once it will become 50, 60, 30, likewise. It will not remain constant. So that is your dynamic holder, which is very, very important. And flooding point, the vapor upcoming velocity is higher than the downcoming liquid, then your liquid will suddenly fill with the column will suddenly fill with the liquid. That is your flooding point. Got my point? Now up to 200 degrees centigrade, after completing all these things, I will stop my distillation. I will wait for the next day. Then I will shift my distillation inside. Only I will add only vacuum pump. Now again I will show you the mechanism, manual mechanism. Now come here.
Teacher, the vapor of water collected in which is the
Vapor of water. Water. We don't need the vapor of water.
draining here.
See, exactly. See, if there is a high water into the crude oil, that is why I have given bypass. You can say the bypass.
Collected where? Here?
See, some water is collected here, and the boiling point of the hydrocarbon near to water. Obviously, that hydrocarbon will carry that water along with that hydrocarbon.
Good.
That will passes through into the receiver.
This is naphtha. You say.
See, don't mix all together. First you are doing the dehydration.
Dehydration water here. And what is it?
Dehydration, some water will collected over here, and some water which is passing through into the receiver. This is your first step.
We need up to 105.
With naphtha, exactly. So what you have to do is that you will have to separate it out.
If we want to separate water from naphtha.
Exactly. Yes.
Ah.
Because the density of water is
Not
high.
all of water for crude oil here.
Yeah, it will collected over here only. Then you will have to separate.
How much degree for Celsius water? About
We have a product
100,
water.
105 degrees centigrade.
100.
Why I am saying 105? Because there should not be any drop remain inside the crude oil, because it will create the hurdle during the distillation process. Because if it will create the hurdle, it can crack your column. Isn't it not?
So during the removal of water, we can also remove the C1 and C4.
That you will collect over here. You can connect this balloon over here and there is a stopper.
So three operation conducted at the same time.
Yeah.
Remove of water and remove of the
Exactly,
C4
LPG
and
potential.
C1. Okay.
Exactly.
This water, distilled water.
This is what?
Distilled
So water you get here. So you get a water here, you get a water cross there, and you get a C1 to C3 through here.
Anachemsha 105.
That goes,
From that connect.
that goes to the box.
There is a salt also.
Akitenga pale na ukaitaka juu
It is also to dissolve in water.
akihit up to 105.
That you cannot do. Okay. Okay, so after completing the distillation of 200 degrees centigrade, as I told you, keep one thing in your mind. Maybe Dr. Gupta ji, who is training in charge there, he may ask you. Definitely, he may ask you up to which temperature we can do the distillation in atmospheric pressure and in under vacuum. So, as I told you, LPG potential, naphtha, and half part of the kerosene. Half part of the kerosene means up to 200 degrees centigrade or maximum 225, not more than that. We can run our fractional distillation under atmospheric pressure. Okay, so keep one thing in your mind. If somebody will ask you, you just explain them. Up to 200 or 225 degrees centigrade, we can run.
Why is that?
Why is that? So that there should not be any cracking. We are avoiding the cracking. Okay. Yeah, this question may be asked. Why we are stopping the distillation? So to avoid the cracking.
Thermal cracking.
So I will shift to avoid the cracking. Now I am going to shift my 200 plus because we have 200 plus left now. So I will shift here and I will connect the vacuum pump. See, there is a vacuum pump. Pump is there. Yeah, just side by side. Yeah, this is vacuum pump. That vacuum pump. This one? Exactly. So that pump I will connect through this tube. Now, before explaining all these things to you, I want to share you one story. Okay. Initially, what happened when we started this running the unit under vacuum? What I have done, this is the unit, and we don't at that point of time we don't have any manometer. This is manometer, so we are unable to see how much pressure is running inside the unit. Okay, so what I have did, I directly connected my vacuum pump through this and just switch it on. So the minimum capacity of this pump is 0.5 mmHg. Now 0.5 mmHg. This is the capacity, maximum capacity of my pump. So what happened?
Without cooling system,
There is a tap water. Tap water is there. So what happened? This is my experience which I want to share with you. There is no heating inside the flask. What I have did, directly I switch on the pump. What happened? My edge such 200 plus flows inside this and passes through into the manometer. Means pressure is very, very high. So I got confused how I manage so that it can segregate, because directly I switch on and my pump giving the maximum capacity, that is 0.5. So my 200 degrees centigrade boiling point compound at 0.5 mmHg is not segregating. It is coming as such out. So that point of time I thought, what should I do now? Is there any way where I can give some thrust or some brake? At that point of time there is no manometer, so that my liquid is passes through and drop there. So my whole the things up to 200 degrees and that is goes down. So I will have to start again further from starting. So second thing, what I thought okay, should I put thrust between unit and pump? So create some idea and thought, should I give one glassware where I will put some mercury in between pump and unit. So I add some mercury for thrust so that my pressure will not go directly into the unit. Okay, so little bit it works. The capacity of pump is 0.5. When I put the thrust in between, then pressure little bit goes down, then it become 10 mm Hg. But again, same thing happen. My liquid passes through this and reaches here. Again, what should I do? Here I thought, should I distribute my pressure into two ways. One should come in the unit, second should come into the manometer, and third the way where I can control. So I find some idea, I just open it and connected through this particular valve. This is my regulator. So how this idea comes? I just think myself, if I will disturb this thrust up and down, because this is a thrust, if I can manage this thrust up and down, maybe there will be a changes in pressure. So what I thought, I connected two way, this and two way over here only. One is going into the manometer and one is going into the unit. When I switch on and I keep this regulator at the topmost area, when I switch it on, my pressure will be at 50 mm Hg. So suddenly it retain at 50 degrees, 50 mm Hg. So yeah, 50 up to 510 directly 50. So my any drop is not coming out of it. Now again confusion, because I have to distill it. So how we can do this? So I gradually heat up that residue 200 plus, but again heating is reaching up to 200 degrees centigrade, but sample is still not coming. Not again I cool it down and let it come at 90 or 95 degrees centigrade. Again I disturb this regulator. How? Just keep there, keep in your eye over here. When I lift it up and down, is there any disturbance in the level?
Yeah.
So level of mercury goes up and down. So this is the miracle for me basically. When I reduce it at lower side, suddenly my liquid lift up and reaching in condenser area.
Nobel Prize.
Not Nobel Prize, but that is
The change of pressure during reducing
exactly. So
What was the change of pressure?
at that point of when my liquid reaches in condenser area, I see my manometer. At that point of time, my pressure is 30 mm Hg. Now I come to know the crude oil which I am distilling from 200 onwards, where I am going to get the remaining part of the kerosene from 200 to 250 degrees centigrade, and 250 to 370 degrees centigrade, that is your diesel part, that has to be maintained at 30 mm Hg. Now when I set up the 30 mm Hg pressure, gradually my segregation is taking place and I am getting my product 4 to 5 ml per minute. Then timer is started. Now when my kerosene cut has been finished up to 250 degrees centigrade, now gradually my product is reducing. Again I got confused. What should I do? Because now your boiling point is higher. So up to 300 degrees centigrade, distillate is there. But after 300, it stopped completely. Again, same thing is coming. Should I again drag it down? Lower or higher? Again, I drag it down. My pressure become 20 mm Hg, and suddenly my liquid reached up and it started coming. So what I find from it, if crude oil is very light, so beyond 200 plus, you can keep your pressure 40 mm Hg. That is there. But if crude oil is very high, and you want to distill further from 200 to 370, you can maintain the pressure at 20 mm Hg, you will get the things. So that is why this is the innovations further. What should I do? Otherwise we don't have automatic unit. So when it works, so we have distilled so many crude oil, whether it is heavy, whether it is light, or is any type of crude oil. So here I have distilled up to 370 degrees centigrade. We have collected the remaining part of the kerosene and the straight and diesel. Yes.
Boiling point is a function of temperature and pressure.
Yeah, exactly. Yes.
In all cases, you take kerosene at 200 degrees temperature, and vapor is 50 millimeter mercury. So, if you reduce the
Pressure.
pressure, the more vapor will evaporate at that temperature. So,
Good
two,
question.
two
Good.
parameters should be assigned.
Yes. Yeah, that is the things which I have to let you know. No problem. Yes, obviously. Now, let me start from the initial part. When you are running the distillation under atmospheric pressure, at that point, actually nobody asked this question. Only you asked this question that I come to know. Okay. As I told you, when there is a 140 degree centigrade temperature, so you come to know, okay, my naphtha has been completed. See, my dear, if you are taking the temperature of thermometer 140 degrees centigrade, it means you are collecting the sample which is not 140 degrees centigrade, that is near about 145 or 150 degrees centigrade. Why? Because you are running the distillation in atmospheric pressure, but we will have to maintain the report at 760 mm AET. That point of time there is two type of correction. I will apply my two type of correction, that is your stem correction and pressure correction. Because the pressure, atmospheric pressure of Dehradun is 710 mmHg. So I will have to note down the 710 or 708 mmHg. But when you are sending the report, that has to be maintained at 760 mmHg.
So you have
But
to make corrections.
yeah, there will be a two type of correction. Keep this thing in your mind. One is stem correction, second is pressure correction. Okay. So pressure correction is obviously pressure. What is the atmospheric pressure where you are working? Okay. And second is stem correction. What is that? That is very, very important. See, the thermometer which we are using for the distillation, this thermometer is completely immersing type. IMM is written in the thermometer.
MP.
Completely immersing type means when this thermometer has been produced, the marking which is there, it has been marked once complete the length of this thermometer from this to this, it has to be kept at 0 degree centigrade from top to bottom. They mark 0 degree. Again, temperature is increased 1 degree. Again, from this to this, it is again 1 degree. Then it is marking in this way. This type of thermometer is called completely immersing type. Got my point? Now, when you are doing the distillation process, is your thermometer is completely in heat contact? I don't think so. Some part of the thermometer is directly in the contact of heat and some part is exposed. Got my point? If there is a exposed, definitely there will be a difference in temperature.
Sure.
So for that you need a stem correction. That I will let you know, I will give the formula and all that. Even I will give a one problem based on this.
Sure.
How will you calculate? Okay, so that is stem correction. Yeah, formula and there is a graph and there's so many things. Whatever you will ask, definitely I will give you. If you never know, don't ask, then how can I? Okay, so that is your stem correction. So this is not a completely emerging type. So for that you will have to apply the pressure correction. So when you are running the distillation under atmospheric pressure, so two correction is required. Now come to the vacuum distillation. Here now pressure correction is not required because you have already set the pressure at 40 mmHg. Got my point? If you have set up the pressure at 40 mmHg, only you require stem correction.
The report is at 760. I'm supposed to have these products and these temperatures at 760 mmg.
Okay, there is a graph. There is a graph, you can convert it into a 760.
Yes, so this will be a type of correction.
I could not understand.
So this will be a type of correction.
See,
Type-
what
Time
actually
of
happens
correction.
is that
Time of correction.
Time of correction.
you will have the pressure at 700 and you will have during the atmospheric correction we have 710 atmosphere mmHg pressure here. So to convert 710 mmHg to 760
It will increase.
mmHg, we will have some of the empirical formula.
Yeah, obviously.
In millimeter mercury, there is in atmosphere.
That's the whole report. Finally, you have all
Achha, whole data. Okay. See, when you once you have collected the data, that data has to be converted at 760 mmHg through. I have a chart, TBP chart. Here is that. I will show you that chart. Even the temperature which we require, we have there only. As I told you, if your pressure is 30 mmHg, your 200 boiling point will be 100 degrees.
I'm working with Thomas. I'm in Thomas' department. I'm working with you.
We have a pressure chart. We have a pressure and temperature chart. Once you have collected, see, your pressure is 40 mmHg. You have collected the diesel cut from 250 to 370. Okay. Now you have noted down what is the temperature at that point of time at 40 mmHg. For example, if the temperature is 355. Okay. So 355/40. So when pressure is 40, at that point of time, temperature is 350, and if pressure is 760, then what will be the temperature? Obviously, it will be higher. So yeah, that is a chart where you can convert it.
Okay.
Okay.
And the final report will give us these numbers.
Yes, obviously.
Thank you.
Now, after completing these things, now the residue which is left, that is long residue. 370 plus or long residue.
Academic residue.
Or you can say RCO.
Yeah.
Somebody can ask you, what do you mean by RCO?
Reduced.
Reduced crude oil. So what you have reduced something?
Yeah.
So that is why it is also known as RCO. Okay. Reduced crude oil or long residue. RCO.
No.
Or obviously you can say atmospheric residue, but here we are doing manually. Yeah, atmospheric residue is there, but we have run the some part of the crude oil under vacuum and some atmospheric pressure. So the proper name is RCO, or you can say long residue, reduced crude oil. Now 370 plus. Now we are further unable to distill that 370 by 2892.
Yeah.
Now we will have to shift that 370 plus in ASTM 5236, where you will get LVGO, MVGO,
and
HVGO. LVGO means light vacuum gas oil,
Vacuum gas oil.
middle vacuum gas oil, and a heavy vacuum gas oil. Now the boiling point is 370 to 400 degrees centigrade, that is your LVGO. 400 to 450 degrees centigrade,
MBGO.
that's your MBGO. And 450 to 550 degrees centigrade,
570.
550, 560, 570. But in general, it is 550. Vacuum residue is there. Now I will let you know. So the 550 plus, which is remaining there, that is your short residue, that is your wrong residue, or that is your feed for the whisk breaking unit. So first I will show you that unit. Let me show you the unit. See, this is your high vacuum distillation unit or pot still high vacuum distillation unit as per ASTM 5236. Here, as I told you, you can get LVGO, MVGO and HVGO. But there is one problem. Here, pressure is always less than 1. Now you can think of atmospheric pressure is 710 and you are reducing the pressure less than 1. So this is just simply a bomb. If there is any mistake during the distillation, it can explode.
Less than one.
Less than 1. So what is the problem? Here you cannot collect the product as per ASTM 2892. Once, as I told you, once naphtha has been connected, you have closed the fraction cutter and drain out the receiver. but here you cannot. If you are doing such type of things over here, so you will disturbing the high pressure and time and again. So there one problem will occur. Maybe once you have collected the one cut, if pressure is not maintaining inside the flask, maybe there should not be any distillate further, or there will be a cracking inside the flask, or maybe distillation will stop. So to avoid the time and again disturbance inside the column, then what is the way? Because we will have to distill this further part of the crude oil. So for that, what we will do, we will take the 200 ml of the sample of the 370 plus or long residue.
Where is the heat done?
No, heater is there. Heater is there.
With the
That will connect
connect
to
with
this. This I will connect this. This is the regulator.
yes, connect with this.
That I will let you know. That I will let you know. Let me finish first. Initially, you cannot directly connect it, or you cannot collect the product according to 2892. So what we will do, we must have a data according that data, so that there should not be any disturbance during the distillation process, because it is running in high pressure. So I will take 200 ml of that residue and distill in ASTM D1160. This is again a distillation. ASTM D1160 vacuum distillation. Yeah, ASTM D1160. 11, not 1160. 1160.
This is vacuum pump.
Vacuum. This is vacuum.
So why are you taking those residue today? It means that's higher compound.
Yes. So that why I am taking that, I am coming that point. So I will take, because if there is any problem during that distillation, so only I have taken 200 of sample. If there is any problem, so only I just miss only 200 ml of the sample. But here I am taking 500 ml of the sample. If it destroy 5 kg of sample, if that destroy during the distillation, so how will you complete your distillation? So first I will go through by D1160. There what you will get, that distillation is just like a D86, but only, can somebody explain what is the difference between D86 and D1160?
Through the pressure.
That is
This is the vacuum.
and this is
This is
it.
the atmosphere.
This is the very basic question. What is the difference between D86 and D1160? Basic difference is, this is atmospheric and this is under vacuum. Both are the qualitative distillation process. Both are the qualitative distillation process. Again, question can arise, sir, how can you say that this is qualitative analysis? I'll let you know. The naphtha which you have collected by the fractional distillation. So how will you decide this naphtha is compatible for benzene, compatible for toluene, compatible with xylene, or how much part we can blend with the gasoline, or we can blend with the benzene? For that you need the D86, because in D86 you will get IBP and recovery at 5% volume. If you are getting the maximum recovery at 5% volume, then your mindset will be what? Rather than to making a petrol, it is better to prepare the benzene, because you are getting the maximum yield at 5%, and we know that our BTX cut is 70, 90, 90, 110, 110, 140. These are our hard cut of the crude oil, which require for the benzene to making the benzene, to making the toluene, to making the xylene. So by D86 you come to know, okay, which part we are getting at which temperature. Got my point? Similarly, what you will do, you have taken the 200 sample and you are going to distill by that D1160. There you will get initial boiling point, and what is the 5% recovery temperature, what is the 10% recovery temperature. For example, if my 400 degrees centigrade recovery volume is 10%. Got my point? 10% recovery at 400 degrees centigrade. Now obviously you come to know, if you have taken the 5 kg of the sample, 5 kg multiply by 10% volume, now you will get the volume. Similarly, if it is 20 or 21%, so 21% multiplied by 5 kg, you will get that much volume. So from that particular unit, you will get the volume, idea of the volume. What is the exact idea of the volume from 370 to 400, 400 to 450, 450 to 550. Once you have collected the volume percent, so how much volume you are taking here? Suppose if you are taking 5000 ml, multiply 5000 ml by 10%. Obviously, if you if you have taken the weight by weight, suppose, then you have to convert this volume into weight, because when you are converting the percentage, so your unit should be in same condition.
Either it will be percent volume or percent weight.
Either weight should be volume or percent weight.
Where is the draining here?
I will show you. I will show each and everything. Draining and all that. Okay, now, so you have collected the data. How much volume we can collect? Now, no need to disturb the things whatsoever, because you know what is the collection volume from 370 to 400. You have noted down. For example, it is 500 ml. You collect the 500 ml of the sample. Now come to the point. Here is no reflex media. Reflex media is absent, but there is an interaction media. And also the design of the column is itself in such a manner, there will be a partial interaction between vapor and liquid. Okay, so first I will show you the column, then I will give you the answer of your question.
This is
This is good. This is without the drain.
I will show you the drain.
See, Thomas outsourcing
So this
his.
is the distillation column. Again, this column also prepared by silver coated by HS Martin, USA.
USA.
Yeah,
Made in India.
made in USA. Made in USA.
I think made in India.
Not made in India.
The pure glass or pure glass or
Pure glass, pure glass. Each and everything I will discuss you. What is this is there? What is this there? Let me just finish this one. Yeah. So yes, your answer. First you connect this here. Then there will be a fraction.
Now I can take a picture all of it.
Okay. You will connect this column over here. Then there is a fraction cutter. Okay. And behind that there is a distributor and receiver. 6 receivers we can connect all together. There will be a 6 receivers.
Receiver now, naphtha.
No. Now you are getting the lubricating oil,
The lubricating oil.
lube oil.
Lube oil.
So first lube oil, second lube oil, third lube oil.
Yes.
Okay. Once you have connected, you will get somebody can hold it.
So do you want to can we identify the DuPont?
Yeah. Please hold it.
Without cooling system here.
There is
Only
a,
vacuum.
we are using no cooling. For cooling we are using ice.
Ice.
I will keep ice
This is
over
what
here,
ice here.
for icing trap is there. Now I will show you what you want.
So in all, 4 different distillation units, right? You have one there, one there, one here, and one across there.
This column, this is your fraction cutter. Once, for example, 400 volume has been collected, you will close, and this is your distributor. So how it work? I will show you.
Then where is the receiver? Receiver is this one?
Receiver connected in behind.
okay.
Okay. See, once 400 had been completed, you can rotate this one, because this is a distributor. It is distributing the liquid. So under vacuum, you can rotate. Here once I will connect my receiver. There is a receiver. I can show you the receiver.
Okay.
This is the receiver. For my 370 to 400 volume is 500 ml. This is 500 ml. Once it has been completed, you can connect over it. So such type of 6 cylinder I can use. 6 times. So I can get 6 distillate
The first cylinder, what? Bio crude oil? Not bio.
by that long residue 370.
The second,
Desiccant.
the second what?
Okay. Second is, first one is LVGO. Second one is MBGO.
MBG.
And third one is HVGO. Okay. So once 500 has been collected, you can rotate like this. I will rotate it.
Another of this.
Then another one. You can rotate
last
another
one.
one. So you not need to disturb any pressure.
The last one, asphalt? No.
Yes. Last one is short residue. Short residue. I will just let you know.
So there's
Got-
6. You only mentioned 3.
So
So
you
what are the
can
3 more?
rotate.
Six, not asphalt.
So I am not disturbing my pressure.
Not like this. First one.
What about this one?
This is for releasing. Last.
break the
For
pressure
example, you
to
have
remove.
collected means three distillate. Okay. After collection, until if you are not releasing the pressure, because this is under vacuum, so you will have to release the vacuum first. Then you can get the product.
Yeah.
So where you will release? You just hold. You can release this by rotating like this. So whole the unit will connected through here. Once it has been connected through here, then you can take it out. It has to be connected through a wire.
The water collected.
That's why
I want to say
Yes.
that the system is evacuated.
I'm
Yes.
holding.
Evacuate. If there are any leaking possibility, it will hamper.
If your grease is not evenly over there,
The water
definitely
collected.
there is no any cooling, not this side, because now you are getting the product which has boiling point more than 370. So
The
if-
water collecting. Where?
What
Here?
here at 370 degree, how will you get the water?
What is across there?
Crude in this oil.
Here you are the distillate, you are getting the lubricating oil from 370 degrees centigrade. Here you are taking in the
You cannot
flask.
collect water here.
My dear, the product which you are taking for LVGO, MBGO, or HVGO, the boiling point of that product is 370 degrees centigrade. So how water will remain at 370 degrees centigrade?
Not like this.
Yeah, that is initial, because there is a boiling point 20 degrees centigrade. My boiling point of water is 100 degrees centigrade, but here boiling point is 370
But
degrees.
when you are make vacuum, the boiling centigrade not 100, maybe less than,
Where?
because PV equal MRT. When you less the pressure,
Yeah, that-
the temperature less.
Obviously, that
The
is
boiling temperature
here-
not 100.
here you are boiling. So you are taking.
What actually happens?
This is vacuum.
In the first stage.
Make a pressure less,
When,
Once,
when,
once. Yeah,
when
this
you are
less
distillating an
pressure.
ASTM,
like swallow.
when you are working on ASTM, all the water in moisture content is removed from there.
Is removed from
That
there.
sample is
Yes.
transferred here.
Here.
Actually, the water, only you will get the water there only, by that unit.
So the sample from there,
Only.
yeah, and the sample from there is being transferred.
Here only you are
It's the
getting
same sample, right? So the sample from there is being transferred. So there's no water here.
Dehydration already.
Yes.
DIC already, we have
Yeah.
already done the dehydration, no water is there.
Yeah.
Contains this some water.
There is no any water.
No, the water has been removed from over there.
Dehydration unit.
And the crude from there now is taken across here to
Same
get these
sample.
other
The
fractions.
same sample.
So you already removed the water there.
Yes.
Yeah.
This is also
And the light
very-
hydrocarbon.
3 point must be seen.
So remove the light
This is
hydrocarbon.
the crude oil.
No, but it's the crude oil from there that you
You
already
say the
removed.
dehydration unit already. You remove water, you remove C1, C2, C3.
You remove naphtha,
And after you come the
some
residue here.
kerosene, and then you transfer across here to remove
But you will
the,
not remove all kerosene. Some
Just a part of it.
Some of part of it. Then you come here.
yeah.
Under pressure to remove the heavy.
No,
There's
no, he think that this is
No.
heating.
The crude oil already, that is the
What process heating this?
The crude oil,
sample there.
the crude oil that was processed there is transferred here. So that portion is already collected.
wait, there is a receiver.
Heating kerosene.
As picture.
You bring the receiver.
Receiver. So you're getting everything?
Yeah.
Everything is in the receiver. Nothing is going bounce.
I'm working with him.
Now your
With
answer.
Okay.
So got my point? Now, yes. Now how this column is working? Now that is important. This is again just like a TBP distillation column.
Oh, hello.
And yes, please. And it just evaporated.
Yeah, focus. Very important.
And it is
Botswana.
again it can hold the pressure which is 10 to the power minus 6 mmHg. Now how it is working? Now you can see your answer. How it is working? See, you just watch inside what is there. There is a cup type and there is a hole.
And a hole.
Now see.
Like a
Yeah.
cup and a hole.
A small hole.
So there are 1, 2, 3, 4 of them.
Here you can see. This is
That's
cup
called
type and there is-
column.
Yeah.
So how it is working? I let you know. Let me explain first.
Sure.
Got?
There are 1, 2, 3, 4 cups.
There is a 4 cups. Now somebody can hold. Let me explain this. This is the example of semi-fractionating distillation.
Semi.
Semi-fractionating.
No
Why
pen.
it is? Because there
Pen
is
in a
no
pocket.
any reflex media, but there is an interaction between vapor and liquid.
Turn it.
So it is cup, then there is a hole, then again cup, then there is a hole. So what is happening? Vapor is reaching up. So vapor is not that much intelligent, it will pass directly from this point. Vapor will first reach here. So after reaching here, obviously there will be a condenser. Condensation, the liquid is going back. So vapor is coming, liquid is coming back, there is an interaction. So there is a 1, 2, 3, 4 interaction is there.
So equilibrium
somehow,
again.
yes, somehow vapor and liquid are interacting each other.
Thermodynamic
So that is
equilibrium.
exactly once equilibrium is generated, the lightest product will passes through this point and reaches to the condensation area. Here we will use ice cubes, or we can use the liquid nitrogen.
Like from here to here.
Yeah, connected there. After condensation, that liquid will passes through into the fraction cutter and distributor and into the receiver.
And again there will be the receiver.
Just like them.
So
Yes.
receiver here, receiver.
Here fraction cutter,
And then,
then distributor, then collector. Got? This side will connected through this. This side will connect.
You understand?
And there is a pulley.
this is also cool. You said
Inside that one, ice cubes are there. Ice cubes. So this way, you will get LBGO, MBGO, and HBGO. Now.
And then in the flask there will be the residue.
Yes, remaining is the residue.
What is that residue?
One interesting thing I want to show you.
The residue is between.
Not between.
Makeup.
Let me not
wait, please. Why you not be definitely
I want to set up one like this at our university. This is interesting.
Now, I want to tell you one interesting thing. If you are interested, then. Do you know earlier the name of this unit was not pot still high vacuum distillation unit. Earlier the name of this unit is Sarnia high vacuum distillation unit. Sarnia. SARNIYA. Sarnia high vacuum distillation unit. Now it has been obsoleted. Obsoleted means only they have changed the design of the column. Earlier this column is simply hollow type, but the type itself can interact the vapor each other. See, as I told you, vapor is not that much intelligent. Directly passes to do and go there.
Yeah.
Vapor will first reach here, then condense, then there will be interaction. Again, lighter will reaching here, condensation, then interaction. Again, the lightest will passes through this one. But there is a little bit problem. of purification. By this we are not getting proper purification. That is why they have obsolete this one. So this one has come and name has been changed, and the name of this unit is partition vacuum distillation unit. Okay.
So this is old and
Old
this,
one.
This is
Old one.
abandoned one.
Yeah.
So now you are not using it anymore.
No, we are not using. It is only kept due to our ancestor has kept this one.
Oh, your sister.
We can take that to the museum.
Ah, yeah.
Museum.
Yes, yes. It is indeed. Now,
Now whatever we are seeing is the upgraded one.
upgraded, yes. Now, what is the uses of LVGO, MVGO and HVGO? That is more important. The boiling point 370 to 400 oil. After oiling the waxing, the oil which is remaining, that
Sure.
we can use for the machine oil.
Excuse me. Sure. When do we carry out the waxing? After we receive the sample from 370 to 400, we will.
Before that, no. From where we get wax? No. Correct answer. Correct question. See, another important question is there. Where is the exact point where paraffin appears? That is the main question. Now, when we have a narrow cut distillation, one see before going through these long fractions like 140 to IBP 140, 140 to 50, we try to do the narrow cuts. Why? So that we can guide the TBP curve properly. Because as you know, the maximum point if you have, then you can draw the good graph. So for that, what I do, I just prepare 3 distillation of 25 degree gap each. For example, from IBP to 50, 50, 75, 75, 100, 100, 25, 25, 150, 150, 175, like that. So this is the basically experience. When you see the cut from 250 to 275 onwards and 275 to 300, these two cuts suddenly down in density.
So
See, initially it is lower,
they have
then
the reduced
higher,
density.
higher. Suddenly your density goes down. At
250
either
to 300.
250 to 75 or either 275 300 or 300 325, again 325 to 350 shoot up, and it is higher than the initial cut. So the where your densities goes down
There's a
at
wax.
particular point of time. Now you come to know my wax appearance has been
Increased.
now
Increased,
you come
rised.
to know, okay, rise where a paraffin wax has been appeared. That will goes down definitely. And second thing, you can see when you, I think you have not seen the TBP curve. Your TBP curve, when you draw the TBP curve, your TBP curve goes like that. Then suddenly goes and then similar straight line. Means this again match each other. But this area disturbed due to that appearance of paraffin.
There's a density drop in density.
Yes.
Yeah.
That is due to paraffin wax.
So this is volume versus density.
Yes. And again it is going high because after that you will get the crystalline wax, which is heavy in nature. But your paraffin is light in nature, that is why your density goes down. So this way your TBP curve will be there. Okay. So your LVGO you can use for machine oil and other oil also, and MVGO, that is for lubricating oil. That is high stable. But now the HVGO, that we cannot use for any purpose. That is high vacuum gas oil. That is a feed. That is a feed for the FCC unit.
FCC.
For hydrocracker. That HVGO, float catalytic cracking, that HVGO we will put on that, then again we will crack. When we will crack this again, the naphtha which we will get from that HVGO, that will be the far better than the naphtha which we are getting from the crude oil. Because the crude oil directly we are getting the naphtha, it has got straight run compounds. But the naphtha which we are getting after cracking, it has got the double bond, triple bond compounds, where that will increase the octane number. That is the main purpose. because we will have to improve the efficiency of the fuel.
So the isomerization will occur.
Ice will occur definitely. Obviously, and what is our main purpose? Obviously, our main purpose is to improve the octane number.
Octane number.
Then what is the octane number? Obviously, the octane number is an index by which we can justify our fuel, which type of fuel it is. Okay, and the kerosene which we are getting from that is also good, and diesel, that is also good. Okay, and the remaining part which you are saying that is bitumen, it is all that. First, it is simply a short residue. This is simply a short residue.
Long residue, short residue.
The short
Long
residue.
residue will go into this
into the-
unit, and after that
You
come
will
into
get the short
this unit.
residue. Short means we have short like that. Long means it has got something more.
Yeah.
So short residue 550, 565, all this. So this is
So
short
C100
residue.
plus,
Yeah.
C100 plus.
Oh, yes, 100 plus. Now, this is the short residue, or you can say this is the feed for the visp breaking unit.
HCC.
You can again crack it to increase the viscosity. That is why it is called visp breaking unit. Again, we can crack it. Again, we can get naphtha, kerosene, diesel. First, feed for the visp breaking unit. Or you can say this is the raw material for the bitumen. Not bitumen, but raw material for the bitumen. Because for bitumen you need ductility, you need penetration, you need it flash point. So many things are there. Because penetration is a very, very important test. Because in high temperature, if it is just melting it out, then what is the use of bitumen?
Asphalt.
Asphalt.
Yeah,
So
asphalt and bitumen.
first it is raw material. To prepare it bitumen, so it has to
Yep.
pass through the so many tests.
And then we have to use the additives.
Yes. And now you can think from starting from crude oil as such and ending up to the last, everything has been used. So that is why it is also known as black gold.
Black gold.
Black gold.
Yeah.
Gold.
Black gold, yes. I think you have heard sometime what do you mean by black gold? Black gold is nothing but crude oil is also known as black gold. Because black gold. Because we are using each and everything.
Now it's becoming like this.
Yeah. So all has been finished from here. Now the important question which is very, very important, which I will ask you, and if you don't have an answer, then I will let you know. Okay. So
Question.
come this side.
Question.
Are you?
So, sorry, I have a question to Mr. Thomas. Mr. Thomas, where are you?
Sorry, sir.
It's coming to you, don't worry.
See, you have seen the column. It seems it's made of silver, isn't it? But it has been silver coated. Why?
Sorry again.
This is made of glass, obviously, but it seems it is made of silver. But it is silver coating.
Inside.
Outside. So what is there? Why it is so?
Light.
Like what?
Light from
It's the
To prevent the light, you mean?
thermal isolation.
is isolation.
Yeah, thermal.
Correct answer. To avoid the losses.
Of heat.
Which type of losses? Due to convection and radiation.
Yeah.
This answer should be in your tongue, dear. You are engineer. Isn't it now? So why we have coded this one? So that there should not be a losses due to convection and radiation. Because outside there is a cold, inside there is a heat. Again, outside, inside, outside. The vapor which is inside should not come out.
Should not
and the
interact
outer
with
vapor should
what
not
So it's
go
basically
inside.
a closed system. A closed system.
Closed system, and that is why silver coating are there. So that your lighter vapor will reflect. It should not go inside. That is the main reason. So this is the coating, silver coating, due to there should not be any loss due to convection and radiation. Correct? Second question.
Or let's say to maintain the perfect
Adiabatic
Adiabatic
condition.
condition.
Correct. Why these threads? It seems like a bangles
Yeah.
has been weared by somebody.
Yeah.
So these cracks, why that is there? I will meet you after 2 minutes. Let me washroom.
Now I'm the lecture. Oh, yes. Any question?
Thomas.
Any question?
Professor Thomas.
Reply.
Why multi-layer?
Yeah. So Professor Thomas is asking a question to
You see, I'm a chief.
Viscerole. Viscerello.
Any question?
Yeah, Professor Thomas is asking you a question.
Please go and ask the lecturer.
Thomas Gale made your research.
Yeah.
It's the Vicom.
Yeah.
Vicom.
Why is that?
Vicom pump.
Where's my
What is this function? What is the function of
I'm not sure.
these cuts, these groups?
Oh, the layer.
Plates.
Maybe the number of plates.
Yeah, plate.
One,
Holding the
two,
plates?
three, four,
Holding the
five.
plates?
Not holding plates, but the structure.
So what was the question?
See, it could have been built plain.
Why do we have this kind of
This groups.
clusters like that?
Can we call them groups? Groups,
Segregation, yeah. Sections.
sections, and groups.
Sections where you have
I mean, the way that vapor goes, it's not straight. I mean, there is a plate and there is, I don't
yeah.
know.
I think
Maze like
I think that maybe this is hollow.
No.
No.
Inside there is a
Oh
column.
yeah.
Column that
Yeah. We can see the column.
Yeah, the column is inside, and in the outside we have this column. And this column will the pressure will be applied into this column. I think.
Maybe these are cooling sections. Maybe where you could lose some you could have some level of convection and radiation.
Name.
They are actually using the silver coating for stopping the convection and radiation.
But then look, you have these cracks here, you know, where you don't have that.
These are several volumes, certain volumes, each of them. Like step by step, one step, second step, third step.
See, this part do not have this material.
Are these the plates?
Yeah.
Why
So why multi-layer? Yeah. Multi-layer.
why this is there?
Yeah, multi-layer. Because multi-layer for filter and thermal.
For making waves.
No, I have shown you the inside and structure already. But what is this? Partition. No partition is there. See, actually, when you are in 10th class, okay. Is there any question? I think definitely because 10th class is 10th class. Is there any question in your science? Why there is a gap between railway track?
What? Yeah.
Why there is a
Yeah.
gap between railway track, train?
Direction.
Thermal expansion to mitigate the damage.
Exactly. Glass
Expands on heating.
due to heating.
So
So this
accommodated
is
that.
called expansion bellows. Third, little bit question, but very important.
Practically in industry, this is outer coating, glass internal.
Thermal what?
They are between
Expansion.
outer coating and glass fills refractory material. Insulating material.
Balloons?
Yes, there is a column.
Thermal expansion.
Have their insulating materials here.
Inside this,
double-
maybe I didn't see any water inside there, because but
Thermal expansion.
Completely work from outside.
yeah, we have a method.
Is it?
I'm listening. Trying to listen. Yeah.
Any other analysis part, there is a automatic
I'll
also.
wear the bangles.
But the distillation is fully manual.
So why are the bangles
All this need to be distilled
bangles
fully
of
manual.
silver?
See, think
Have
of
the groups in it.
automatic one is 2 crore.
Why are
It
these
is
groups
only
being
7 lakhs.
placed?
And the work which we have done by this column is
What expands here? Do the
There's a
silver?
heat inside.
So what will expand
we
here?
have all these, we have done all these.
The silver?
Not the silver inside.
Then what will expand?
I don't know.
So these are the
What is this
expensive
made of?
metals.
It's made of glass.
Now got my point?
And the glass has the silver coating.
Yeah.
Got me?
Yeah.
Now my second question is,
That was second question.
why why these expansion bellows had been the upper side only? Why it is not in lower side?
I'm going to ask about this question.
It is only at upper side. Why it is not lower side?
Pressure
Because the
is higher.
pressure
The
goes up.
temperature is also higher inside.
Actually, see, expansion may occur. Expansion may occur due to interaction of water and oil vapor. Obviously, at home you can see when you are frying rice and all, you just add some water on that, there will be a fire. But here you are dealing with hydrocarbon. If once there is a fire, then definitely you will go. And there will be dhopati and all that. So it is here only. See, there is a high heat. Okay. So the vapor of the water will definitely reach at condensation area.
Yes.
After condensation, your liquid of water definitely first interact in this area. So that is why expansion, maximum expansion of glass may occur from this to this point. So it can wear the expansion. Otherwise, if it is not wearing definitely it will crack. So that is why it is giving at top of the column. So maximum chances is there to expand.
Theoretical plate.
Yes.
Theoretical plate.
No, not the theoretical plate. My brother, my friend, what actually happens? It might have the moisture content. It might have the water. When it comes up to the condenser, then it might interact with other hot vapors, oil vapor, and when the oil vapor and water are in interaction, they will form fumes.
And where did you
That
put
will-
this one?
So there should
This is
be
an
any
insulator.
heat loss.
Yeah, insulator.
Insulator.
Insulation only.
Keep the heat inside.
Dear Chief, did you understand?
So in this unit, in that unit, this
These
kind of condition will not
same,
occur.
no, this is same type of unit, only this is for dehydration process. Dehydration. To remove the
remember-
water.
And another thing is that it acts in a relatively lower temperature than this.
Done
Then
this
yes,
here.
exactly. It is working at atmospheric pressure or it is working under vacuum.
Here we are working up to 225 degrees Celsius at max. But here we are going to work up to 370 degrees Celsius.
370 degrees.
And the pressure is lower here.
Pressure is high here, so you get more.
Yes.
Yeah, you're already working on the
Simply while
pressure.
in Charles law.
Pension.
Due to temperature.
No, it's not extreme.
So where is it that you will do, like, you mentioned a different fraction by just changing, by varying the temperature a little, so you could have that region where you could get you mentioned there's another system across there?
No, that is different type of system.
Okay.
Here you can get one, as I told you, up to 370 degrees centigrade. You will get the cut one by one. Once you have taken naphtha, then second time kerosene, then second time diesel, likewise.
How much time does it take for one run?
One
full
run, 20 liter run, 5 days. It is taking 5 days when it is running day and night.